Welcome back. We're going to continue this video on graphs, digraphs, and PageRank, and our next topic will be digraphs. Digraphs is a shortened version of directed graphs. We can write directed graphs as an ordered pair, just like we write the undirected graphs. We still have the same vertices. Nothing changed with the vertices, but now the edges, instead of being undirected, are directed. So edges, instead of being subsets of size 2, are now ordered pairs. We still won't have any self loops or multiple copies of edges. So how should we think about digraphs? One way to think of them is to think of a neural network. The neurons are vertices in the digraph. The synapses from neurons to other neurons are edges, directed edges. Another way we can think about digraphs is in terms of the internet. In this example, the vertices are websites. The directed edges are links from sites to other sites. In a digraph, there are multiple possible cases that we can have for the edges between two vertices U and V. It's possible that we don't have any edge from U to V or from V to U. That's one possibility. Another possibility is that we have an edge U to V, but we don't have an edge V to U. We could also have no edge U to V, but an edge from V to U. And then there's the fourth possibility, that we have both an edge from U to V and an edge from V to U. So what is the maximum possible number of edges in a digraph of order n? Well, this is just going to be twice the maximum number of edges for an undirected graph of order n. The maximum number of edges in an undirected graph of order n is obtained by a complete graph of order n, because a complete graph has all the possible edges in it. So we get the number of edges in the complete graph of order n, which is n times n minus 1 over 2, and we multiply that by 2, which gives us n times n minus 1. And we can think of that as taking each edge in the complete graph, and we just have it going in both directions. So that's the times 2 is the both directions. Let's look at a few more definitions related to digraphs. First, the out degree of vertex V is the number of edges from V to any other vertex. The in degree of vertex V is the number of edges from other vertices to V. Here's another problem for you. Prove that the sum of the out degrees of all the vertices in any digraph is the number of edges in the digraph. And that brings us to the end of part 2.